So let's look at one more of these concavity problems. So let's look at this example. Determine the open intervals on which the graph of the function f of x, which will be x squared plus 1 over x squared minus 4, is concave up or concave down. So we need the derivative. And here we're going to have to use the quotient rule to find the derivative. So the derivative of the numerator is 2x minus the top. The derivative of the bottom is 2x over x squared minus 4 squared. And if you simplify the numerator, if you distribute out, collect up your like terms, f prime of x will be negative 10x over x squared minus 4 squared. But because I'm talking about concavity, I need to keep going and I need to find the second derivative. F double prime of x. So the bottom, the derivative of the numerator is negative 10 minus the top. The derivative of the bottom, you're going to have to use the chain rule. And then you're going to square the bottom. So when you square a square, it's going to become a fourth power. And if I notice, all of my terms have an x squared minus 4 in them. Every term in the numerator and denominator. So I can factor one out of the top and cancel with one of them in the bottom. So I'm going to have one copy left here. Let's go ahead and make minus minus a positive. I have no copies left here. And then it'll be x squared minus 4 cubed. And again, if you multiply out the numerator, simplify it a little bit, you'll get 30 x squared plus 40 over x squared minus 4. And you can factor out a 10 out of the numerator. So if I try to set this equal to 0, well, what that really gives me is that 3x squared plus 4 equals 0. And this equation there's no solution. But I do know that the second derivative is undefined when the denominator is equal to 0. So that means x is either plus or minus 2. So on my number line, I'm going to put a negative 2 and a 2. And I'm going to pick some test points smaller than negative 2, so negative 3. The easiest number between negative 2 and 2 is 0. Pick 3. And you're going to plug them into your second derivative. Now, if you look, the numerator is always positive. Here, the numerator is always positive. So just look at the denominator to decide if it'll be positive or negative. So if I plug in negative 3, it'll be 9 minus 4, so it'll be positive. 0, it would be negative 4 cubed, so it would be negative. 3, it would be positive. So again, where's my graph concave up? It's concave up anytime I have positives. It's concave down whenever I have negatives. So my answer is concave up on the intervals negative infinity to negative 2 and 2 to infinity, and it's concave down on the interval negative 2 to 2. And there's my description of when it's concave up or when it's concave down.